Okay, welcome to this short video. I'm just going to show you how to use MetaPairwise. So you'll see on the screen, I've got it up here. You can access it through this link here, which goes directly to it, or you can access it through our Terra set of tools, I should say. So this is what it looks like. It's a beta version, so it's still in the process of getting developed. So this is the earliest version they've got so far. We've given them some feedback, but if you're able to use it and give me any other feedback, I can tell them about it, and hopefully they can address it in the next version. So anyway, so this is the home screen, which sort of gives you a whole lot of information about it. Then we're going to go to click on this tab up here called with data, and so we're going to select our data set, the statin study. So if I go select here, and then I need to find where it is on my computer. So here it is here, data for workshop. Oh, is it data for workshop or stat? It is this one, data for workshop. Okay, so, and it's in the format that you can see here that it needs. It gives you two options here, continuous outcome or binary. So in this case, we've got a binary outcome because it's heart attack or no heart attack, so it's binary. And then you can see here what the data looks like. We've got the study column, the treatment group column. I don't know why it's called R, but that's the number of events. And then N is the number of patients. And you can see here it's been I should say it's been split up into the different treatment groups within the different trials. So then if we go to calculator here, it gives us some options, and here we've got select our reference, which is placebo. That's correct. We're going to choose a random effects model because, as you saw, hopefully in the presentation, you would expect heterogeneity because these different types of statins, different doses, the populations are different, either primary or secondary or both. The outcome is probably being measured differently as well because unlike all-cause mortality, myocardial infarction is probably it's not actually black and white outcome. Sometimes in these big trials, they get an independent adjudication committee to sort of say whether or not someone's had a heart attack. And then I would suggest you would normally look at relative effects and absolute effects. So we can choose risk ratio because it's a RCT, and so we can estimate risk ratios, and they're often easier to interpret than odds ratios. And then we can just press run frequentist analysis, and this is what it produces. So it tells you how many studies, 16. The pooled estimate is 0.72. Confidence interval 0.67 to 0.78, p-value 0. So that means there's a 28% reduction in heart attacks in the statin group. Heterogeneity, you can see here, the I-squared value is 57.8%, so that's kind of moderate heterogeneity maybe. And the p-value for testing heterogeneity is 0.003, so strong evidence that heterogeneity exists, which basically means each study's measuring a different treatment effect. And you can see here, here's the forest plot. We've got the placebo group here, the statin group here. Then we've got the number of events and the number of people who didn't have an event. So you can see that's a bit different how it's done that. And then it's got the weights ranging from anywhere from the most is about 12% right down to a study which only provides 1% towards the summary estimate. Then you can also see there does seem to be some heterogeneity because there is some non-overlapping confidence intervals. And then you've got the random effect model here, this estimate here, 0.72. The fixed effects, you can see it's got a much tighter confidence interval because it doesn't include the between studies variation in the estimation. But also the effect size is pretty similar. And then you can see here, you can download your forest plot as a PDF or PNG file. So yeah, if you've got, so that's about it. I'm gonna do the risk difference next. But if you've got any comments, let us know, and we can feed those back to the people, University of Leicester, who have developed this. So if I now go to choose risk difference and then run the meta-analysis. So now we're looking at absolute risks. So that means it's not comparing the ratio of events, I should say the ratio of risks. It's now looking at absolute risks. So the numbers will be a lot smaller. So this is basically a difference between the proportion of people who had an MI in one group minus the proportion who had a MI in the other group. So as you could imagine, it makes the effect size look smaller. In fact, you can see here that, or maybe I'll go through it. So you see the I squared now is 89%. So it's much, much higher. So there's a lot more heterogeneity when you look at the absolute effects. P-value for testing heterogeneity is 0. And then you can see here, this study here is a bit of an outlier, isn't it? Right, 4S. It's got a huge, well, I should say, yeah, quite a big absolute risk difference between the two groups in this study. I'm not sure why that is. 8%. But then if you look at the random effects model, the estimate is 0.02, so 2%, and that's a confidence interval there. You can see it excludes the null value, so it's statistically significant. But then if you look at the fixed effects model, it's a much, much tighter confidence interval. The estimate is a bit smaller, but essentially what it tells us is that the statins appear to be effective in reducing the absolute risk of myocardial infarction by about 2%. So I'm just going to stop there, and yeah, hopefully this is useful. And once again, apologies because we couldn't do this yesterday. So I'm just going to stop